So in previous session, we have started our discussion about what are the type of operators we have in Verilog, and we have started with normal arithmetic operators. Arithmetic operators we have plus, minus, multiplication, division, and modulus. These are your basic operators. And coming to logical operators, we have logical and logical or and logical not. That we had a very good detailed discussion in our yesterday's session. Anyways, you can reverse the recordings that will be uploaded soon. Okay. Now coming to today's session, we will start with discussion of relational operators. Okay, and after that we will go to bitwise operators. Okay, first we will start our discussion about our relational operators. Okay, so these are our third type of operators which we are going to start our discussion, which is nothing but our relational operators. So in the relational operators, what are the type of operators which we have? Less than operator, greater than operator, less than equal to, greater than equal to. These are our relational operators. Okay, less than, greater than, less than or equal to, greater than or equal to. Okay, not more much about these operators. Just we already know these are our basic operators. Let us try to implement them in the tool. Let me show you some examples of using this less than operator, greater than operator using our tool. And let us consider some scenarios and let us try to discuss them. So I'm going to create a module which is known as example, and in this example I'm going to declare two variables of 4 bits, a and reg 3 down to 0 b. Okay, and within an initial beginning block what I'm going to do is I'm going to assign a is equal to 4 tick, a is equal to 4 tick binary 1011, and b is equal to 4 tick binary 1100. Okay, now let me declare one signal, and in the case of your relational operators greater than or less than, or greater than or equal to, or less than or equal to, your result will be only single bit. Okay, either it will, if it is greater than, if the condition is satisfied, then your output will be 1, or else if the condition is not satisfied, your output will be 0. Okay, so let's take one variable reg greater than. This is my greater than, and reg less than, and this is reg greater than or equal to. Okay, and reg less than or equal to. Okay, these are my outputs which I'm going to consider. So what I'm going to do is greater than is equal to a greater than b. If a is greater than b, then my GT signal will be equal to 1. How to display it? You are going to use a system task which is known as $display, and you're going to write the value of GT is percentage b, or you can use percentage d. This percentage b, percentage d, these are all your format specifiers. Percentage d is one of the format specifier used for displaying decimal numbers. Okay, and percentage b is the format specifier you are going to use it for displaying binary numbers. Okay, and percentage h is for hexadecimal numbers, and percentage o is displaying for octal numbers. Okay, these are your format specifiers for displaying your numbers. In which format you want to display in that particular thing, you can mention that. Okay, now what are you doing here is the value of GT is percentage b, comma, what are you going to write is GT. Okay, followed by n and n module. And after this, what you can do is just select the tool, that is Aldeck, and save this and run this. You can just click on run, so it will start executing within an initial beginning block. Wait a minute, I'm getting some error. So what is the error which we are getting? Okay, I have missed the semicolon. Semicolon. Yes, let's run it again. Yes, so the value of GT is equal to 0. Why the value of GT is equal to 0? Because A is not greater than B, A is less than B, so that's why GT is equal to 0. And if we are using less than, if we are using LT is equal to A less than B, and if I am displaying this $display, if I am writing this LT, then I will get LT as 1. Okay, let me run this. LT is equal to 1. Okay, now this is my LT. LT is equal to 1. Now let's say if my A is equal to 4 tick binary 101x, and B is equal to 4 tick binary 1100. Can anyone tell me what is the value of GT in this case? A greater than B, and dollar display the value of GT is percentage B comma GT. Now what will be the value of GT? It is either 0 or 1 or X. What do you think? What will be the value of GT? So in this case, the value of GT will be X. Okay. Why? Because this is your don't care value. 101X is don't care. It is treated as don't care. This whole value is treated as don't care. And we cannot compare this with your 1100. So that's why we are getting as don't care. Okay. Now, similarly, if we try to perform LT less than operation, A less than B, then also we are going to get don't care only. Let me copy this and paste it over here. LT is don't care. If any one of the bit is X, then your output is equal to don't care. And next we have one more operator is greater than or equal to GTOEQ, which is equal to A greater than or equal to B. Okay, GTOEQ. Okay, let us display this GTOEQ. Copy this and paste this. Obviously, we will get don't care only. Okay, it is going to just compare A greater than or equal to B or not. Okay, yes, and coming to less than or equal to, I think there is no need to explain that. These are very simple basic operators. Okay, now next type of operators after this we have, after relational operators, we have equality operators. So for the type of operators which we are going to have is our equality operators. So in the case of equality operators, we have two type of equality operators. One is logical equality operators. Logical equality operators. In this logical equality operators, we are going to have double equal to and not equal to. Okay, and we have one more equality operator which is known as case equality operator. So this case equality operator which we are going to have is triple equal to and not double equal to. So these are our two type of operators which we are going to have, logical equality operators and case equality operators. Let us try to understand what is this. First of all, let me declare the variables reg equal. This is my normal equality operator, and reg not equal. Okay, and another is reg case equality operator and reg case not equality operator. These are my two operators which are variables which I am declaring here. And let's say the value of A is again, let's say it is this value. I'm going to paste it over here. Since the two values are not equal, if I perform equality operation on this, then your answer will be equal to 0. Equality, which is equal to A double equal to B. Okay, let me display this and let me show you what I'm getting. Dollar display the value of equality is percentage B comma CEQ. Okay, so in this example we are going to get CEQ as 0. Since these two are not equal, so we are going to get our output as 0. Here we can see the value of EQ is equal to 0. Okay, now let us see one more thing. Sorry, it is not CEQ, it is normal EQ. I'm using normal equality operator, right? Let me run it again. Yes, the value of EQ is equal to 0. Okay, now followed by case not equal to. How to use this case not equal to? CNEQ, sorry, normal NEQ. NEQ is equal to A not equal to B, and let me display this. And here I am going to use NEQ. The value of NEQ is equal to, here it will be equal to 1 because these two values are not equal. So that's why I'm going to get my NEQ value as 1. Here we can see. Okay. So this is about your normal equality operators. Now let's say if your value of A is this 101x and value of B is 1100. Let us take this. Let us perform normal equality operation on these two variables. And let me display this. Okay, so my value of A is equal to floating binary 101x and the value of B is equal to 1100. I am displaying the value of case equality. I'm basically displaying the value of case equality. Okay, let me save this and run this. So in the case of case equality, you are going to have three equal to symbols, not two equal to symbols. Okay, sorry. First, I will display normal equality symbol. Then after, we will discuss case equality. So normal, let me declare it as EQ1. Okay, EQ is equal to A double equal to B, where A is equal to 101x and B is equal to 1100. Let me save and run this. So in this case, we are getting EQ is equal to 0, where here A is equal to 101x and B is equal to 1100 and EQ is equal to A double equal to B. You are using normal equality operator, and in this case, you are getting EQ is equal to 0. Is it clear up to here? Any doubts or any queries? Okay. Yes. Now let's take one more scenario where your A is equal to 4-tick binary 00x0 and B is equal to 4-tick binary 1100. Now let us display this case equality. Sorry, let us display this normal equality. I'm getting case equality. Let us display this normal equality double equal to. So here also we are getting 0 because these two are not equal. So we are getting 0 only. Okay. Yes. Now let us use this case equality. CEQ is equal to A case equal to B. Okay. And let me display this case equal to also. So case equal to also I'm getting 0. So normally if you are using your Vivado tool, you are going to get don't care when you are using normal equality, because your normal equality operators cannot compare your unknown values. So this EDA tool is compromising it to 0, but actually what is going to happen is, if you are using another tools like Vivado or Model Sim, if you are using normal equality operator, like let's say suppose if A is equal to 4-tick binary 110x and B is equal to 4-tick binary 1111. Okay, and if we are using C is equal to A normal equality of B, then in this case you will get your answer as don't care. Normal equality operators cannot compare this, but in EDA playground you are getting 0. But if you use another tools like Vivado or Model Sim, you will get unknown. Okay, and if you are using case equality, let's say suppose C is equal to A triple equal to B, then you are going to get 0, because your case equality can compare unknown values also. So since these are not compared, so that's why in the case equality operator you will get 0, whereas in the case of normal equality operators you are going to get unknown. This you should be little bit careful depending upon the tool. This EDA playground is compromising those values to 0. But normally speaking, if you are using Model Sim or Vivado, you are going to get, in the case of normal equality operators, for this operation you are going to get unknown, and if you use case equality operator you will get a 0. That was about your equality operators. Okay, so we have discussed about relational operators and equality operators. So after relational operators and equality operators, we have another type of operators which is known as bitwise operators. So in the case of bitwise operators, we have bitwise NOT, bitwise AND, bitwise OR, bitwise XOR, bitwise XNOR. Okay, let us try to understand what is this bitwise operators. So let me declare some variables: reg bitwise NOT, reg bitwise AND, reg bitwise OR, reg bitwise bitwise OR, bitwise XOR, and reg bitwise XNOR. So these are my operators which I am going to use. Okay, and in the case of your bitwise operators, as the name itself suggests, bitwise, between each and every bit your operations are going to perform, logical operations are going to perform. For example, if your A is equal to 4-tick binary 1100 and B is equal to 4-tick binary 1110, okay, then if you perform bitwise AND, that is if you write A and B, then the bitwise operation AND operation will be performed on each and every individual bit. 1 and with 1, 1 and with 1, 0 and with 1, 0 and with 0. This is what it is going to happen. So 1 and with 1 is 1, 1 and with 1, 0 and 0. This is your final result. Whereas in the case of your logical operators, entire value is treated as either logical 1 or entire value was treated as logical 0, and the AND operation was performed on those two values. But in this case, in the case of bitwise AND operations, operation will be performed on each and every individual. So this was our bitwise AND operation. Let us try to understand this bitwise AND operation. And in the case of in the case of your logical operators, when you are using this logical operators, your output was a single bit. When you are using this logical operators, your output was a single bit. But if you are using a bitwise operator, depending upon the width of your each and your variables, your output will be decided. Okay. Now let us see the examples of this bitwise operator. So let's see this bitwise operator. If let's say A is equal to 4 tick binary 1010 and B is equal to 4 tick binary 1101. Okay. And first let us perform bitwise and. How is bitwise and? B and is equal to A, only single ampersand. In the case of logical operators, we have double ampersand, and in the case of bitwise operators, we have only single ampersand. Okay, let us display this dollar display. The value of B and is percentage B comma B and what should be the value of this register? This width should be 4 bit because your variables are 4 bit width, right? So output will also be a 4 bit width. Okay, so let us display the value of B. We can see here we are getting the output as 1000. If we are doing AND operation between each and every bit, we are going to get output as 1000. Okay. Now let us do the bitwise OR operation. How to perform bitwise OR operation? Your output will be of 4 bits. Okay, 3 down to 0 B OR. Okay, so let us do the bitwise OR operation. How to do the bitwise OR operation? B OR is equal to A or B. Only one line. Okay, and let me display this bitwise OR operation also. Bitwise OR is percentage D or percentage B. In binary format, I want to display it. Let me run it. It is 1111. If you perform OR operation between this, you will get 4 ones. Okay. And let us perform bitwise NOT also. B NOT is equal to simply NOT of A. Okay. And it will also be 4 bit. Okay. Let me save it and let me display this B NOT also. The value of B naught is percentage B naught. So it is B naught is nothing but 0101. So what is your A value 1010? Complement of 1010 is 0101. Okay. And this is our bitwise NOT operation. After that we have bitwise XOR operation. Our output is of 4 bits. Let me perform this bitwise XOR operation. So bitwise XOR is nothing but A XOR with B. This is the symbol for your XOR operation, cap symbol. Okay. Let me copy the display statement. It is bitwise XOR. So bitwise XOR is 0111. If you perform the XOR operation between these two variables, you are going to get your output as 0111. Okay. And we have one more operator which is known as bitwise XNOR. Okay. This is of also 4 bit because your A and B are of 4 bits, right? So that's why your resultant will also be a 4 bit. Now how to perform bitwise XNOR? Simple. Just write it down. B XNOR is equal to A XNOR with B. This is your symbol for your XNOR. Okay, let me display this. Okay, it is 0. Okay, sorry, I'm displaying XOR only. Let me display XNOR. So it is 1000. If you perform XNOR operation between these two bits, you are going to get 1000. So this is how you are going to perform the bitwise operations. And let's say if you have a don't care values in your bits. Okay, let us take that scenario. Let me copy this and paste it over here. Let's say if a is equal to 40 binary x0 1x and b is equal to 1100x. Okay, let us perform all the operations. Let me copy this. Let me copy all the operations, bitwise operations. Where is this bitwise operations? Yeah, from here let me copy everything. Paste it over here. Okay, let me run this. So we can see here bitwise AND is x00x, bitwise OR is 111x, x10x, x11x, x00x. Okay, so whatever the bit you are having as don't care, any operation will not be performed, any bitwise operation will not be performed on that particular bit, and remaining bits respective operator will get performed. Whereas in your case of your logical operators, depending upon the analysis which we have done in our previous session, that particular analysis will be performed and your result will be given. Okay, so this is how you are going to use your bitwise operators. Is it clear? Any doubts? Then what will answer we will get for bitwise operators in model sim on Vivado? Bitwise or equality? Uh, is your question on bitwise or equality operators? I think your question is on equality operators, right? The same answer we will get. The same answer we are getting, right? I have told in model sim or Vivado we will get in the case of your normal equality operators when we are comparing don't care values you will get unknown, whereas we are comparing case equality operators. If we are using case equality operators we will get 0 or 1. That I was saying. Okay, yes. So that was about your bitwise operators. Next, we have reduction operators. So how this reduction operators are going to work is, if you are using this reduction operator, you are going to use only one operator. For example, this is your reduction and this is your reduction and operation. What is going to happen is if you are writing a is equal to 40 binary 1010, then and operation will be performed on each and every bit and the resultant will be given. For example, 1 and operation with 0 and operation with 1 and operation with 0. So 1 and operation with 0 is nothing but 0, and this 0 and this 1 and operation will be performed and the resultant will be equal to 0, and the AND operation between these two will be performed and the final result will be equal to 0. This is the final result which will be given. So in the case of your reduction operators, the final result will be a single bit value. Okay, the final result will be a single bit value. Not only this bitwise and every reduction operator. This is bitwise and, this is bitwise NAND, this is bitwise or, sorry, this is reduction or, this is reduction NOR, this is reduction XOR, and this is reduction X NOR. Okay, let us try to understand one by one by taking the same example. Let's say our A is equal to 4-tick binary 1010 and B is equal to 4-tick binary 1100. Okay, we don't need one more variable. Reduction operators deal with only one variable. Okay, now let me declare those variables first. Reg, reduction and, okay, reduction and reg, reduction or reg, reduction nor, reg, reduction NAND, reg, reduction XOR, reg, reduction XNOR. Okay, I will write down the symbols also so that it will be clear. This symbol is not, this symbol is simple ampersand, and this symbol is OR, and this is XOR, and this is XNOR. Okay. Yes. So the same symbols only we are going to use for this reduction operators also, but we are only going to use this symbols on single operator. Let's see for reduction and, which is equal to and ampersand of A. Okay. Let me display this. Let me copy this and display it. The value of reduction and is percentage B, comma, reduction underscore and. So what is the value of your A? A is equal to 1010. A is equal to 1010. So AND operation will be performed on each and every bit. Okay. So your final result should be equal to 0. So what is your final result? We are getting it is equal to 0. Is it clear for everyone? Any doubts or any queries in this? Reduction operators? Great. Now after this we have reduction or. How to perform reduction or of A. Okay, let me copy this. So reduction or it is equal to 1. Why it is equal to 1? If you perform OR operation between each and every bit, your result will be equal to 1. One OR operation with 1, sorry, one OR operation with 0 is 1, and resultant 1, and OR operation this with 1 is nothing but 1, and this 1 and this 0, that is nothing but 1. So final result will be is equal to 1. That is what we are getting. Okay. And after this we have reduction or after reduction nor. How to perform reduction nor? Reduction nor, which is equal to not of A. Okay, sorry, this is your reduction nor. Okay, let me copy this and paste it over here. So this is our reduction nor. Let me display this. So reduction nor is also equal to 0. Okay, complement of your or. Okay. So this is about your reduction operators. I think reduction operators is straightforward and these are simple. Okay. Each and every bit on the same variable operations will be performed and the resultant will be given. Okay. After this we have our shift operators. Okay. So in the case of your shift operators, we are going to have right shift operators as well as left shift operators. Let us try to discuss the shift operators. So we have the operators which is known as shift operators. So in the case of this shift operators, we have two type of shift operators. One is logical shift operators and another is arithmetic shift operators. Okay. So in the case of logical shift operators, we have right shift operators and left shift operators. And in the case of arithmetic shift operators, also we have right shift operators and left shift operators. This symbol is simple this, and this is this one. And in the case of arithmetic shift operators, you have three symbols. And in the case of left shift, you have this. So this is nothing but your shift operators. Okay. How to perform shift operation? Like let's say suppose if you want to perform logical right shift operation, we will talk about arithmetic shift operators later. First of all, let us talk about logical shift operators. If you want to perform, let's say if you have A is equal to 4-tick binary 1101, and if you want to perform logical right shift, what you are going to do? Let's say suppose if you want to perform logical right shift by 1 bit position, that means this is your value and you want to perform logical right shift by 1 bit position, that means your resultant will be 1 1 and 0, which will be right shifted by 1 bit position, and in MSB 0 will be appended. Okay, how to write this? Simply write it down: A right shift by 1 bit position. That's it. This is how you are going to perform right shift operation. Okay. The resultant will be this. Okay. And if you want to perform right shift operation by 2 bits, let's say suppose A is equal to 4 tick binary 1101. And if you want to perform a right shift operation by 2 bits, how you are going to see this 2 bits? So this one will be shifted over here and this one will be shifted over here and remaining 2 bits will be appended by 0. How to write this down? A right shift by 2. You can simply write A right shift by 2. Okay. So this is how you are going to perform a right shift operation or left shift operation. Is it clear? Any doubts or any queries in this? Okay. So this is how we are going to perform the right shift operation or left shift operation. Okay. In detail, we will take one example and we will see about your logical right shift operation and logical left shift operation and arithmetic operations with what is the difference between your arithmetic operators and logical shift operators in our next session. Okay, we will discuss about what do you mean by logical shift operators and what do you mean by arithmetic shift operators. We'll try to discuss in our next session. Yes, so that's about this particular session. If you have any doubts or any queries, you can simply write a right shift by 3